The device you're using has a processor containing billions of tiny transistors, which are just a few hundred atoms in size. These transistors are hyper-fast super switches that can turn on and off billions of times per second and help you process whatever task you want to do. This is all possible thanks to quantum mechanics, a branch of physics that is also used for GPS, lasers, MRI, and even the internet. Despite all this, the applications of quantum physics in everyday life are still in their infancy. Let's explore what else the near and far future holds for us in terms of quantum technology, starting with the basics. To understand quantum mechanics, it's important to know that a particle's state properties cannot be predicted with absolute certainty, but only with a range of probabilities. This means that the particle is not in any given state, but rather in all states at once until observed. An example of this is the famous Schrödinger's cat experiment, which demonstrates how particles can exist in a superposition of states. Schrödinger's cat is a thought experiment proposed by Austrian physicist Erwin Schrödinger in 1935. It is a paradox that illustrates the probabilistic nature of quantum mechanics by demonstrating how a system can be in multiple states at once. In the experiment, a cat is placed in a sealed box with a bottle of poison and a radioactive source. If an internal monitor detects the radiation, the poison will be released and the cat will die. According to quantum mechanics, the cat is both alive and dead until the box is opened and one of the two states is observed. The experiment is used to show that quantum systems can be in a superposition of states and that observation affects the outcome of the system. Rather than the traditional binary bits of zeros and ones, quantum computing uses quantum bits, or qubits. These qubits are individual photons that can be both 0 and 1 at the same time, much like a coin that is continuously spinning and holds the possibility of being either heads or tails until it is stopped and looked at. However, the true state of a qubit cannot be observed without disturbing or changing it. So why use qubits when regular bits work just fine? Qubits offer many advantages, such as the ability to represent the value 0, 1, or a superposition of both. Quantum cryptography is a method of transmitting secure data over optical fiber using qubits instead of classical bits. It relies on the quantum properties of these qubits, which are photons with polarizations, to secure the transmitted information. A photon can have 4 states of polarization: horizontal, vertical, diagonal to the right, or diagonal to the left. Horizontal and diagonal to the right polarized photons represent qubits with the value of 1, while the vertical and diagonal to the left ones represent the value 0. If a photon with horizontal or vertical polarization is measured using a rectilinear filter, it will be measured correctly without changing its value, similar to measuring a diagonal photon with a diagonal filter. When a rectilinear photon horizontal or vertical is measured with a diagonal filter, the photon's polarization will become diagonal, either to the right or to the left. The sender will polarize the photons accordingly to transmit a series of zeros and ones, but they will randomly choose between using rectilinear and diagonal polarizers. The receiver will also measure the polarization of the photons using a random filter for each photon. The sender and receiver will then share the scheme and filter they used for each photon and any bits of information. Quantum entanglement, also referred to as spooky action at a distance by Einstein, is a phenomenon in quantum mechanics where 2 or more particles become interconnected such that the state of one particle can immediately affect the state of the other particles even if they are separated by large distances. This seemingly violates the principle that physical events cannot travel faster than the speed of light, which made it appear spooky to Einstein. However, it is now known that no violation of causality happens as information is not actually transmitted between the particles. Quantum entanglement can be used to enhance the security of quantum communication. One application of quantum entanglement is quantum teleportation, where information can be transferred between locations without moving the physical matter that holds it. This allows for completely unhackable quantum networking, known as device-independent quantum key distribution, which enables wireless, fully secure quantum communication. Alain Aspect, John Clauser, and Anton Salinger have recently been awarded the Nobel Prize in Physics for 2022 in recognition of their experiments demonstrating the reality of quantum entanglement, as well as their contributions to the development of quantum technology. This has been further explored in a paper titled Traversable Wormhole Dynamics on a Quantum Processor, which examines the similarities between quantum entanglement and wormholes, concluding that they are possibly the same phenomenon. To test this, the researchers created a quantum entangled system in Google's Sycamore quantum computer and studied the properties of information transferred through it. They found that these properties were similar to those of a theoretical wormhole. By combining quantum devices in a working quantum network, along with some quantum cryptography and quantum entanglement, the perfect setup for a quantum internet is created. The quantum internet promises to revolutionize the way we use devices and networks, with significantly faster speeds and stronger security than current technologies. This new network is based on qubits, which allow for an exponential increase in speed compared to traditional networks. Furthermore, its quantum-level encryption makes it more difficult for outsiders to intercept or access information transmitted through the network. In the face of the 2020 pandemic, the need for a quick vaccine development was made urgent. In the past, vaccine development has taken anywhere from 5 to 10 years. To speed up the process, tech giants and research labs, such as NASA, utilized the High Performance Computing Consortium, a group of supercomputers. This consortium was able to perform calculations 50 times faster than if every person on Earth did 1,000,000 calculations per second. If these calculations were done on fully fledged quantum computers, the efficiency of the process could increase by hundreds or thousands of times. Quantum technology takes advantage of the fragility of quantum states, making them very sensitive to any kind of disturbance. This sensitivity can be used to create precise instruments for measuring things such as microscopy, positioning, time, and various physical phenomena like gravity, electricity, and magnetism. The Pauli exclusion principle states that no two electrons in an orbital can have the same quantum properties. This has allowed scientists to make a gas transparent, a process called Pauli blocking. This works by tightly packing atoms with high speaking temperatures, such as those from a gas. When photons strike the electrons in the atoms, due to the high density, the electrons can no longer absorb the kick and scatter the photon. This makes the atoms transparent. Having this technology at our fingertips, even on a device smaller than our phones, can be likened to having a full rocket's worth of sensor equipment in the palm of our hand. It also explains why we can see things. When photons encounter atoms, there is an exchange of momentum causing the photons to be scattered in all directions, including into our eyes. Quantum technology is quickly moving from being a concept explored in sci-fi movies to a reality that will have a significant impact on our daily lives. From nanobots manipulating the fabric of the world to the potential for teleportation, quantum mechanics is only going to become more powerful with advances in artificial intelligence. This could lead to machines that are smarter than humans, utilizing the full power of quantum physics to accelerate technological progress. While it remains to be seen whether humans have a place in this quantum AI-dominated future, there are steps you can take now to prepare. We hope you've enjoyed this video, and if you're interested in staying updated on the latest advancements from quantum technology, make sure to subscribe to our channel. Thank you for watching. Not done yet learning about this topic? Continue watching one of our other videos. See you in our next video.